Hello friends, I am Dr.Chishty and I am teaching to BSc third year physics. My today's topic is Schrodinger wave equation and its applications. There are two types of Schrodinger wave equations. One is time dependent Schrodinger wave equation and another is time independent Schrodinger wave equation. So today we are going to study about the time dependent Schrodinger wave equation. So let us consider a wave which is given by y is equal to a e raised to power I omega t minus kx in the exponential form, where omega is the angular frequency and k is the wave constant. Now I will replace omega and k by E is equal to h nu in terms of energy and in terms of momentum. So if E is equal to h nu, then omega is 2 pi nu. So I will find the value of nu from here as E upon h, and so I will substitute it here. Omega is equal to 2 pi E upon h, or omega can be written as E upon h by 2 pi, or omega is equal to E upon h cross, where h upon 2 pi is called as h cross. Now similarly, I will replace the k. We know that k is equal to 2 pi by lambda, and according to de Broglie hypothesis, lambda is equal to h upon p, or 1 by lambda equal to p upon h. This p is the momentum in x direction. So I will substitute the value of 1 by lambda here. Therefore the value of k will be equal to 2 pi into px upon h, or I can rewrite it as k is equal to px upon h upon 2 pi, or k will be equal to px upon 2 pi, or px upon h cross. Now substitute these values of k as px upon h cross and omega as E upon h cross here in this wave equation. It will become y is equal to a e raised to power I into E by h cross t minus p x upon h cross into x. Now I can take h cross common as a e raised to power I by h cross et minus px into x. If I take the h cross common, then equation will become y is equal to a e raised to power I by h cross et minus px into x. Now if suppose there is a beam of electron which is moving in the positive x direction and it has the momentum p of x, then according to de Broglie, a wave is associated with that beam of electron, and it has the energy E, and it is given by a wave function psi which is depend upon the position and time. Therefore it is the wave function psi is also given by the similar value as psi x of t is equal to e raised to power I by h cross et minus px into x. But in wave mechanics this function is negative, therefore psi x of t is equal to e raised to power minus I by h cross et minus px into x. Now I will insert this negative sign. Psi of xt is equal to e raised to power I by h cross p of x into x minus et. Now I will differentiate this equation with respect to t, and I will get here the partial differentiation dou psi by dou t as, here a will be as it is, here a will be as it is, then dou psi by dou t is equal to a I by h cross into e raised to power I by h cross px dot x minus e of e into t. So we are having the wave equation psi x of t is equal to a e raised to power I by h et minus px into x. So we have to put here a negative sign in the wave mechanics, and I will insert this negative sign into the bracket, and I will get here psi x of t is equal to a e raised to power I by h cross p of x into x minus et. Now I will differentiate this equation. with respect to t first, then variable is only e, then the derivative of the exponential is as it is into the derivative of this function, so it is I by h cross into e a as it is. So for a and this exponential function I can write the value of psi, because psi is equal to a e raised to power I by h cross, here h cross et minus px into x. So this will become I by h cross psi into e with negative sign, So dou psi by dou t is equal to minus I by h cross psi into e. I will find the value of e psi from here, minus h cross by I into dou psi by dou t. Now I will differentiate this equation of the wave function with respect to x. Now differentiate with respect to x. So I will get here dou psi by dou x is equal to a as it is, I by h cross as it is, into p of x e raised to power I by h cross p of x into x minus e into t. This is a differentiation with respect to x. When particle is not free to move, then the total energy of the particle is given by E is equal to half mv square plus v, that is the kinetic energy plus potential energy. Now this kinetic energy can be replaced in terms of the momentum as px square upon 2m plus v. Now I will multiply both sides by psi. So E psi is equal to px square psi upon 2m plus v psi. So in this equation I will substitute the value of px square psi from here as minus h cross square dou 2 psi by dou x square upon 2m as it is plus v psi as it is, and for this E psi I will substitute the value as, so I will substitute here the value of E psi as minus h upon I dou psi by dou t, which we calculated earlier. Now I will multiply this by I and divide by I, so I will get here minus h cross square upon 2m dou 2 psi by dou x square plus v psi equal to plus ih cross dou psi by dou t. Or psi can be replaced as a function of x of t, therefore equation will become h cross upon 2m dou 2 by dou x square psi of xt plus v psi of xt plus is equal to I h cross dou by dou t of psi of xt, which is known as the Schrodinger time dependent equation. This equation is called as Schrodinger time dependent equation. So thank you very much.